Hey
Hey,
everyone. Hey Paul.
yeah. Hey, Matt. Hey, Paul. We got two Pauls on today. Yeah, so like happy 2022, everybody, and welcome back. Matt and Paul, like how was your break?
Well, fantastic. It was great to have some time off. I did a little bit of a social media thing prior to Christmas, a little bit of Devember for AWS. So I don't have it with me, but I do have one of my funny hats that the kids loved. But I spent a lot of time with the kids and the family, and it was fantastic. So, what about you, Matt? How did you go?
Nice. Yeah, no, I had a very good Christmas. I worked through it, but I plan to take some time off in March, so that will kind of make up for it. Maybe we'll go somewhere. I don't know. We might go to just like one of those local places where there's a really nice beach and we can take it easy for a week. But I did go to a wedding, which was good. So I ended up going to Hobart. So that's down a couple of hours away from Victoria. That was really nice and beautiful there. It felt like winter though. It's freezing. I don't know how you guys in the US that are watching are coping. Melbourne's really hot. Like it's really stuffy. It's like 100 Fahrenheit. It's been like that the last couple of days, but then it's almost like icy going to Hobart. So a couple of hours difference is huge. Paul, how was your Christmas?
Yeah, mine was pretty awesome actually. We went away to a little caravan park where we had a villa at it's called Meetung, the place is called Meetung near Lakes Entrance. Did a lot of fishing, kids did a lot of swimming in the pool. It was really great to like try to switch off and unwind. But I mean, it's been a really full on and hectic start to the year. So yeah, tough to get back. And like Matt said, at the moment for me, I'm not sure what the temperature is. It's probably like high 20s. I'll quickly just check now. It's probably like mid to late 20s. But it is hot in my shed today. It is really hot. So I can see like my forehead is a little shiny with the reflection there. I'm doing the best I can. And I've got my bottle of water sitting here ready to go. But, at the start today, Matt said something that actually I didn't really think about and I didn't really tweak. So for those that have been coming along, for us, Matt and I and Devs in the shed for the last 6 months, you'll be familiar with the background of my shed. Now, my poster fell down sometime over the break. We had some pretty heavy rain. I think a little bit leaked through and broke the tape off.
No more Rick and Morty.
Yeah, no more Rick and Morty. It's on the floor. But this will be the last episode where I'll be streaming from this particular shed. So I am moving. So next week I'll have a new shed or area, whether I get that set up in time. So yeah, this will be the last time for this shed. We might have to go ahead and update some of our background banners because I'll have a different setup. So it should be really fun.
Yeah, exciting. But like, what are you moving into exactly? Is it like a new shed? Is it a cabin?
Well, the new place actually has an old cabin on the property. So it's a 1920s log cabin, but it is in need of some like restoration work. So I'll try and do the very first episode in there, but it's going to be like pretty rough. I'll probably be sitting on it'll probably be dark and dank and a few spider webs and so forth behind me. I don't know whether I'll be able to get much done at all ready for next Wednesday, but hopefully it'll be there and it should be really fun.
And you've got redundant internet as well, I understand. So you're going to have, just because you are moving a bit more rural, right? You're going to have 2 internet streams. You've got backup, so we can keep the show going, which is really, really nice.
Yeah, that was my first priority, as Matt said earlier. For most of us working in the field, or for basically anybody that's probably watching the stream today, like internet is like water for us. So it's really important to make sure that you've got high-speed internet, and that was one of the things that I invested a lot of time in, making sure that I'll be able to have like commercial grade 4G as a fallback, and Starlink, so the low orbit, low latency satellite internet. So it should be really good.
Nice. I'm interested to hear what anyone else got up to around the Christmas break, if they did anything quite exciting, relaxing. And I did see GetDev did have a question. Paul Colmer, do you have a shed?
So I do have a shed. Unfortunately, my shed is out the back. It's a little bit dark. It's very hot here in Brisbane, Queensland, so not really suitable for a broadcast. So I really do feel like I'm more like the boffin in the office. So hence my office. But great question.
Boffin. What's a boffin? I think some of the Australians and the US peeps probably don't know. It's a UK term, isn't it?
It is, yes. I guess
Yeah.
I never really thought of that. Yeah, absolutely. So a boffin, I guess, in UK and Australian terms is really a bit of a nerd, I guess, someone that likes their tech or someone that's fanatical about something, which is like a boffin. So yes, you're boffin in the office. There you go. Maybe I'll start another live stream, boffin in the office. Obviously not the same time, different time. Don't know. Just an idea.
Nice.
Cool.
Yeah, awesome. Yeah, well, I know, Paul, earlier you mentioned that you did something for Devember. Maybe later you can like share if there's any reference to that. We can have a look at it. Matt and I, along with Aaron and Nelly, we talked about our Devember piece that we did with the Christmas tree, and that was a lot of fun. We had a lot of interactions with the Christmas tree. Over the break, water leaked into my shed, went onto that live stream, and so the live stream is no longer running at the moment. But yeah, that was a lot of fun building out, what happened in November there. But for anybody in the audience, let us know whether you had a good break and where you're coming from. And we'll respond to those as they come up. But this week we've got Paul Comer. So Paul is a machine learning specialist at AWS, like a data scientist, right? And so we've brought him along, and he's going to run us through like a couple of the new features that have come out with SageMaker, and we're going to get hands-on and look through some demos and see what that looks like and see how we can interact with it. And it should be a really good session. So maybe now I'll hand it over to you, Paul. You can give a bit of an intro and kick us off.
Yeah, that sounds really good. Thanks so much, Paul. So as always, it's absolute honor and a privilege to be on this show. It's actually got a bit of a following. I have some AWS hero communities that follow me that sort of talk a little bit about the dev in the shed. So it's a real honor and privilege to be here, which is fantastic. So today I'm going to show some goodies. I'm going to share a little bit of my knowledge with you all on the live stream. And really the idea behind today's session is really to better understand machine learning, better understand a little bit about SageMaker Autopilot, and to try and demystify some of those, strange words, hyperparameters and model tuning and all those type of things that come out of the machine learning world. So yeah, really glad to be here and very excited to do this little demo for you guys. Cool. So what I'm going to do, let me just backtrack a little bit and just talk about SageMaker itself. So SageMaker takes care of the machine learning lifecycle. So SageMaker is a suite of tools. There's lots of different components and features to SageMaker. It probably looks a little bit overwhelming when you first look at the product. But the idea is it takes care of that machine learning lifecycle. So all the way from the data preparation steps, all the way through to the model training, right to the end where we want to deploy our model. And so we're constantly innovating at AWS around the SageMaker offering and constantly adding new features. And it really is designed to take away a lot of the undifferentiated heavy lifting associated with machine learning. So the slither I'm going to show you today, I'm going to show you a little bit of the SageMaker Studio IDE. So that's the integrated development environment. And then we're going to probably focus most of our time on the SageMaker Autopilot, which is like a low-code, no-code offering for training machine learning models. So I'll run through a little bit of a demo. We'll show you how simple some of the code is, and then we'll also show you how to do things in the GUI, which is the no-code version. And you can see there's probably a happy marriage between the two. So let me see, without further ado, let me also take another step back as well. We talked about SageMaker and SageMaker Autopilot, but what problem are we really trying to solve? So SageMaker aims to, like we said, take away the undifferentiated heavy lifting. So the machine learning process can be very time consuming. It requires a lot of knowledge. You tend to need, data science expertise to get the most out of it. You've got to build and tear down your infrastructure, which takes time and money and research. You've got to choose the type of algorithms that you want. You've got to try and get the data into the right format and make sure it's clean. And the types of things that SageMaker Autopilot can do is start to automate some of those things. So we can run things like multiple parallel jobs in one go. We can do automated tuning, and we can do something called pre-processing. So I'll touch on those items a little bit later. What is tuning? What is pre-processing as we go through? Do you guys have any questions before we start?
The one thing I'd like to know from the audience is if they used SageMaker before. Has anyone played with it, made anything with it? I know a lot of people have experimented it within the customers that I work with. So I know it's quite well used out there. I can see, Paul, you've built some simple models, have you? Do you want to tell us about that? Yeah,
I built some simple models for movie suggestions, so just worked through that. It was one of those cloud resume challenges last year, and I worked on that with an ex-colleague of mine, Simon. He sort of got me involved, and I sort of followed along with what he was doing. But I'm also like a co-organizer of the Melbourne AWS Programming and Tools workshop meetup, and we've done a couple of workshops there on SageMaker, and it's been good. It's surprising how quickly you can get something real coming out of that and be able to extend that into an invocable API at the end.
Is that Simon Deep Racer Simon?
That's Carl Deep Racer Carl.
Deep Racer Carl, yeah.
Yep. And so actually that's a good point. So I became involved in Deep Racer really, really early before the console was available, and I spent the whole time using SageMaker, building and training my Deep Racer and exploring like SageMaker at that point in time as well. But no, that's nice. Simon, our friend Simon.
Yep. Okay. Cool.
Good stuff. I was going to say the other tool I play with as well is the AWS Deep Composer tool. So we get time at the end, we can talk about Devember, and again, you can use SageMaker to take the models from Deep Composer, which is around creating generative AI, which is brand new music from models, and you can take this into SageMaker and run those models yourself. So much the same as Deep Racer.
Yep, I do wish I was better at music. I did give Deep Composer a go, and I was thinking maybe I can get a nice hit, some like nice EDM or something like that. And no, you still need musical skills. Cool.
You do a little bit, yeah. Hence the keyboard. You can see it just in the corner there. Yeah, the keyboard there. So a bit of a muso. That's what got me into. I think Deep Composer was my music background, and I think that's why I gravitate towards AI and ML, really, because of the patterns in data, patterns in music, very similar sort of analogy there. But no, it's all good.
Shand is going to be new to SageMaker, so it's going to be exciting to take you through that, Shand, today.
Paul, fantastic.
We've got some new people. That's even better. Do you want me to put your screen up for everyone?
That would be fantastic, yes.
Cool.
Let's put that screen up. I wonder if Chandra is one of my followers. If anyone is following me on Twitter, just let yourself be known. It'd be really cool to connect. Yeah.
Let me put your Twitter details in just so people can reach out if they want to.
Absolutely, yeah. Yeah, that's probably the easiest way to contact me is via digital. Colmer, which is my Twitter handle. One, if you got it there, yeah. And also LinkedIn as well is a good way to reach out. So I love people reaching out to me and helping them with their SageMaker challenges. So yeah, it's good. So fantastic. Yep. Wonderful. So what we've got if anybody's seen AWS before, this is the AWS Management Console. Some of you may not. And what we simply do, you've already logged into your console at this point. And what we want to do, you can either click there, you can see Amazon SageMaker. It's a little bit small on this screen, or you can type it in at the top. So if you type in SageMaker, click on it, that will take you to the next screen. I've got these prepared just because they take a little bit of time to load sometimes. Once you're in SageMaker, you'll notice the first time that you log in that you'll have to create a domain. Now, very simply, a domain is just a collection of resources, basically. So you're going to have an elastic file system share. You'll have one per user. You'll have users you can add. You'll have policies, and you'll have attachment to a VPC. You don't need to worry about all the details. You just need to be able to go in and create a domain. Now, I do have a little
kind of like I guess like a namespace or something with more familiar terminology. Yep,
exactly right. Yeah, that's a really good way of describing it. So excellent. So let me I'll pop the I can't put it in the main chat. I'll put it in the private chat. There's a little link there for people that want to get onboarded with SageMaker Day. We're not going to cover it today. So we click on that. I've already created a domain. You can see there I have 2 users. And all I'm going to do now is launch Studio. So this is SageMaker Studio. This is the integrated development environment. And once I click on Launch App and Studio, you'll then be brought to the Jupyter Lab. And this is what you see on the screen. So what I've done for this demo, I've zoomed in a little bit more so you can see what we're doing. And I think what I'll do, I'll spend a few minutes, just 5 minutes or so, just taking you through some of the basics of the IDE. It probably looks a little bit overwhelming. When you come to the IDE, it won't quite look the same. You won't have all these tabs at the top. These are tabs that I've pre-prepared for this demo. You won't necessarily have all these different files. You'll probably just have a blank file system and you'll need to create some notebooks. But before we get into what notebooks are, let me just go to the left-hand side and just show you some of the key features. So every single user of Sagemaker Studio has an EFS share. So this is what you're looking at here. You simply click on the folder structure there, and you'll see I have quite a few files. The next tab is then showing me the running instance. So I have a virtual Jupyter Notebook instance running. It's running on a T3.medium. You can look up the different instance sizes if you're interested, but you can specify different instance sizes. This one is a 2 virtual CPU 4 gig Jupyter Notebook. We always run the data science app. That is one of the main apps that we run. And then what we can do, we can run a multiple notebooks or kernel sessions. And simply put, a Jupyter Notebook is just a file that contains two things, Markdown language and Python code. And what we can do with the Markdown language, as you can see on the screen on the right there, that's an example of a Jupyter Notebook. You can describe in English what things are doing in the notebook, and you can then create some awesome links. So I'll run through that component in a moment. If I scroll down this file, you start to see some cool code as well. So we can actually have code in here as well. So they're the two types of things that we can do in a notebook. And the great thing about a notebook from a data science perspective is it means we can record our experiments in detail so we can replicate. And that's really, really important in data science, is that when we want to do an experiment, we need other people to verify it and make sure they're getting similar type of results. Hence, that's the basis of science, right? So these notebooks are really, really important concept. Cool. What I'll do, I'll scroll down the left now, just a quick few features. We can connect to a Git repository. Really important if you're having a number of data scientists or a number of machine learning practitioners that are all sharing code. We can store our source code repository in Git, and then we can pull them across as the Python notebooks, and we can edit, and then we can commit back. And that's a really important part of the pipeline. I won't demonstrate that today, but that's really important. Lots of commands that we can look at in a more detailed session, where you guys can explore a bit of information there about what you're seeing in the notebook. Open tabs. This tab is really, really important if you're brand new to SageMaker. This includes what we call the jump starts. So the jump start solution, if I click on Browse Jump Start, you'll notice it pulls up a brand new tab for me, and it shows a range of solutions that I can get started with straight away. So if I look at some of the featured content, you'll see there's quite a range of use cases. So there's some financial services, there's sec filings, use cases here, a whole different range, maybe specific machine learning type problems. And if I scroll down, there's a whole library of solutions. I think there are 15 plus solutions here that you can get started with. So it's a really good way. If you want to get stuck into SageMaker and get started, you can work through these items. You've got text models here, a whole heap of stuff, vision models, tabular models. You can look just at algorithms. Let's look at linear learner. Let's look at XGBoost and those types of things. If we get time, I will go through and try and describe in simple terms what linear learner is. The other ones get a bit more complicated, but again, we'll see how we go for time. And if anyone has any questions, feel free to ask on the comments. Cool.
One of the things I'm thinking for the audience is if they are just getting started, right? SageMaker's one piece. But do you have any kind of reference material that you'd point people's way if they wanted to learn more about machine learning and, particular libraries like PyTorch or TensorFlow?
Yeah, I think the best way to get started with machine learning is through the skill builder. So there's a skill builder site, there's a machine learning plan, and it contains all of the sort of basic knowledge that people can work through. Let me see. I think I might have a link. Let me have a quick look. I'm not sure if I have a link to that with me here, but that's a really good way of getting started.
That's okay. I'll find it in the background. Yeah,
wonderful. But no, yeah, I think that's a really good way of getting started. And what you'll find with the skill builder as well is that, it starts off gently and then starts to ramp up. So if you're interested in doing, for example, a certification, so maybe you want to do the machine learning specialty, which I highly recommend if you're really into your machine learning, then that's a really good way to go about obtaining that. Cool. Now we got to, what did we get to? We got to the jump starts, didn't we, on the left here? Let me scroll down just the bottom. Now this is where a lot of the different features live. So we're not going to run through them all, but if you want to visualize the data, you can look at SageMaker Data Wrangler. If you want to store features and share them with a data scientist, then feature stores are the way they go. You've got pipelines for creating a pipelines, and then there's a few others here. The one that we're going to focus on today is experiments and trials. So that's where this create autopilot experiment lives. And then what we can do is simply click on that, and we can work through this sheet and initiate a series of SageMaker autopilot jobs. So what autopilot does is it allows you to select target data, which is an S3. You designate a source. It can automatically detect the machine learning problem type. You tell it whether you want a complete experiment, whether you want to auto deploy the models at the end of the training runs. And also, if I click down here on advanced settings, you've got the role here, but also you can run up to 250 models at a time. So what we're going to do, I'm not going to run it through, I'm not going to demonstrate through this device, but this is a really quick way of doing it. I'm actually going to take you through the code. And the reason I think I like showing people the code is I want to show you how simple the code looks. And it's a simple copy and paste exercise from the demo, which I'll talk through in a minute, that AWS has published. And it's a really good way of understanding what's happening. And you'll find that reinforce the learning for you. And then you can go back to the autopilot experiment, and you can see how that's driven. So I said I was going to circle back, didn't I, in Python notebooks. Did anybody else have any questions on any of those things? Are we all good?
The audience is a little quiet. Just getting back into the swing of things today.
Yeah, everyone's still in Christmas mode, aren't they?
2022, getting momentum, I guess. That's all good. So what we're going to do, let's run through this autopilot customer churn demo. So I've created a custom notebook here. And what I've done, if I click on this detail here, this is what markup looks like. So very simply, you can use hashes, double hashes, triple hashes, and 4 hashes to give you different heading types, heading sizes. And I've just used some very simple code here. And then what we can do in order to render this, we just highlight the box and we press play. And you can see that's how that works. The same would be true of the code. I can highlight the code and simply press play. And that's the easiest way to get started with a notebook. So what I'm going to do, I've got the original source code here. Let me just click on that link. This is the original demo. And what I've basically done, I've basically followed it and taken the information out and added some additional pieces just for this demo. So some of the pieces I've added are things like, what is cross-validation and what are some of the terminology. So with this link here, let me just pop that down here in the little chat for you to share. That link allows everybody here to follow through a very similar demo that I'm doing here. So everything I always like doing demos that everyone else can have a go at and reproduce. And so this one's no different. So you've got a little bit of explanation, a bit of setup, code. You can see it's a similar sort of format. I've tried to sort of speed things up a little bit. And I'll reference both this original article, mainly around the data types here, and also the demo itself. So let's talk about what we're gonna demo. So no one likes losing customers. It's a costly business. What we want to do with this demo is identify those unhappy customers and give them a chance to stay. So particularly AWS and Amazon, we don't like unhappy customers. We like to keep customers really happy. So that's why this one really resonated with me. This notebook describes how we can use ML for that automatic identification of unhappy customers. So we're going to use a fictitious customer. It's basically mobile phone data. It's been synthetically generated by AWS. And this particular example is an example of supervised learning. And what we mean by supervised learning is that in this case, we are clearly identifying a column that we want to target as our predictive column. So what we're trying to do is determine whether the customer is likely to churn, yes or no. So that's the focus. When we know what we're looking for in a machine learning model, i.e. we know what target variable we're trying to target, that's supervised. Also, if we're labeling data as well, like we might be trying to identify whether a picture is a dog or a car or a human, we would prepare the data with label. That's another example of supervised learning. Very quickly, an example of unsupervised learning is clustering. So we might have a whole series of data points, and we let the unsupervised machine learning algorithm run through and determine how we might group those particular data points. So
would that
generally,
be something, Paul? That would be something like, if you, for supervised learning, you'd have a set that said, I've got 100 dogs and 100 cats. It learns what a dog looks like, what a cat looks like, because it's been told. Unsupervised learning says, we've got 100 different animals and hundreds of photos of each. Go and classify those. Computer doesn't know that an elephant's an elephant, but it knows that an elephant looks like another elephant.
Correct. Absolutely right. Yes, that's a really good way of visualizing supervised and unsupervised learning. And then what this problem then looks at is something called a binary classification problem. So I've already given a little clue as to what that means. We're focused on an output variable called churn, and that churn can either be a yes or a no, a 1 or a 0, a true or false. So binary classification simply means that the target variable that we're looking to predict can only be one of two states. If it's more than two states, it's a multi-class classification problem. So that's essentially the difference, and that's what we're looking at here, is a binary classification supervised learning problem. Cool. Now, Autopilot unfortunately doesn't necessarily support all types of learning. So it supports 3 types of supervised learning. We've already covered binary classification and multiple classification problems, but it also helps with regression problems. And people often ask, well, what's the difference? Very simply, regression is when our output is a number. So, for example, we're trying to predict share prices. We're trying to predict house prices. That's a regression problem. Whereas when we're trying to predict a yes, no for a particular field, that's binary. If it's more than 2 states, that's multi-class. So that's the difference. Classification problems are used for predicting a label, such as customer churn, true, false. Regression problems are used for predicting a quantity, such as house prices in X months' time. So we've got that on the screen there, if you can see that. Cool. That's a little bit about machine learning basics. Let me go through and just walk you through the demo very simply. So first of all, so at the moment, we're going to show you how we get the data into the S3 bucket. And I'll show you the very few lines of code that we need for Autopilot. The other way you can gather the data without using code is you can do it manually. You can download the data. You can put it in Excel. Generally, the data would be probably a CSV format. If it isn't, you probably want to convert it to certainly a tabular format, because that's what Autopilot really likes, is tabular. Certainly CSV is a format that's fairly standard, fairly easy to manipulate into. You could go into Excel, you could go through, you could analyze all the fields, you could run macros on it and remove all of the NAs and all of the zeros and those types of things. But what we're going to do, and Sagemaker does some of that too, we're just going to do this in code just because it's quicker and easier. And what we would do normally, I've already run this code before. This is why we've got a little output here, but we basically want to select the code and then we can simply press play. So if I press play, you see that little output pops out the bottom. So that's our bucket. That's where we're going to store our things. The other thing we're doing here is just setting up the session so that we can use Sagemaker APIs.
The other thing is, like, when I ran and I was getting used to using Jupyter and Sagemaker, was like the 60 that came up in the square brackets. So that way you can determine which cell you ran last.
Yes.
Right. So they increment up. So the very next time we run a cell, that'll be 61. So
correct.
Yeah, that's just something as well that people might want to think of as well.
Yes. And that's important. You'll probably notice that my numbers are out of order because I've been clicking on code randomly. Obviously, the first time I ran it through logically. But since then, I've been playing with this and just trying different things. But yeah, that's right. So the first time you run this, you'll see a 1. But as you click the code, you'll see a little star appear. And that star means the code is now processing, working. And when that star disappears, that number will pop up. So yeah, great call out. We're going to import a whole heap of libraries. We're not going to cover what they are, but these are necessary for this particular demo. We're going to download that synthetic data set. It comes from a public S3 bucket, and we download that to our EFS volume. Once we've downloaded this, we can then run. So pretty much that exclamation mark just drops us down to a terminal session. So all I've done is drop to a terminal session. I've copied the S3 file from the public to my local. It's called churn. And so if I go to the left-hand side, you'll see there's churn.txt. So the first time you were to run this, you would see only 3 files: Autopilot, customer churn, Autopilot demo, and churn, assuming you had the same notebooks as myself. So yeah, if you want to drop down at any point to the terminal, you just use the exclamation marks. That's what we've done here. What we now want to do is inspect the data. So exploratory data analysis is really important as a data scientist. You really want to get a good feel for the data, what it looks like, whether it needs any type of pre-processing. So pre-processing is just a way of putting the data into a format that means it will run really, really efficiently during training. That's essentially what you're doing with pre-processing. What you don't want to do is data that's in a format where the machine learning models are taking a very long time to run, because it will cost you a lot of money. So really important, that pre-processing step. And that might include things like removing zeros, removing NAs, all those type of things. So we've got our data set here. You can see it's basically mobile phone information. So does the customer have an international plan? Do they have a voicemail plan? How old is the last voicemail message? What's their phone number? And we can get a little bit more detail here. We can scroll through. And what you'll find in reality, often when you're gathering data, it's really important to have a subject matter expert that really understands the data. So for example, here we've got one called voicemail message. Even here, they're not 100%. Presumably, the average number of voicemail messages per month. So what I would do in this case is locate an SME, so someone that works in the business that really understands this data, and go, are we sure that's what that data represents? Because what you don't want to do is misunderstand your, we call these features, by the way, misunderstand these features so that we understand how we might use them. So some of these might be redundant. We might clip or kill some of these features, like the voicemail message, for example, might be nothing to do with the likelihood of a customer wanting to stay or not. So that's really important. And again, SageMaker does some of that for us. Cool. So lots of good data. Let's just keep scrolling down. What we're going to do now, this is standard practice. We now want to divide the data into what we call training and testing data. Training data is used to train the model, and the testing data is used to evaluate performance once we've deployed the model. So there's a few steps there, right? You've got the pre-processing of the data, getting it into the right format. We then ingest it as part of an autopilot experiment, we call, and we might run a number of experiments at the same time. So we are going to do that in a minute. We're going to run 20 all at once. And then at the end of that particular process, we then want to measure our training data that we've trained in the model, and also measure the results of the testing data and compare the two. One great thing that Autopilot does as well is something called cross-validation. So normally you would have to do this yourself. You have to write your code, but the Autopilot takes care of it. It does that on anything that's over 50,000 rows, and it uses something called k-fold cross-validation. So very simply, k-fold cross-validation, we take the data set, we randomly split the data set into k equally sized folds. So say k equals 3, we'll divide it into 3 folds, and that's fold, that's number 1. Then we divide it into another 3, number 2, and another 3, number 3. So therefore we'll have 9 folds. And so the first set of 3 folds, 2 of them we'd use for training, and then 1 we'd use for our validation. Second fold, bear in mind the data is randomized, so it's different each time. We use 2 of the folds, and the third one again is testing, and the third will be the same, 2, and then a third for validation. So that way we get a good cross section of randomized data, and we can really thoroughly test whether our model, particularly on small sets of data, is working as it should, gives us the correct accuracy, and is working as we need. But the great thing is Autopilot takes care of all that. So if you didn't understand too much of that, it's quite a lot to take in, probably for the first time. You're not using machine learning. It takes care of it. So all we've got to do is training and test data.
I think Matt certainly had trouble understanding that, whilst I completely understood it.
Thanks, Paul. Yeah, actually, so this is the first time I've really dug into SageMaker for about 2 years now. But yeah. I used to kind of do some stuff in PyTorch in my last place that I worked at.
Cool, awesome. You're ahead of me. I haven't really touched much of the PyTorch. I mainly focus on the built-in algorithms, and that's a good point. You can use other frameworks like PyTorch. You can use the built-in algorithms, and if you're starting out, I'd recommend that. And you can go all the way to bringing your own Docker containers and algorithms if you want to go the whole hog. So this solution is designed at all levels. Today, I'm really showing, the more the beginner end side of things of how it works, but this can go right through to any use case that you want. We have some fantastic clients. Lyft, I think, is one of my most favorite use cases, where they're using machine learning. And I think we're also AstraZeneca is a company that's publicly listed that has used machine learning to gain insights across a range of their data, not just necessarily the COVID data, but a whole range of different data points. So yeah, it's a very powerful tool. Cool. So we'll speed this up a little bit. So basically what we're doing in this next field is we're just randomizing our data and putting it into training and test data. Very, very simple. We're also identifying that we have test data, no target, so we can remove the predictor, so we can do some measurements a bit later on how well we might be predicting without the predictor in the data. Very simply now, we upload the training and testing data to S3, and then we just print those out, and that's what those links are there. So that's where my training data lives. So if I was to go in and run an experiment using the GUI, which I showed you before, we can just pop these components in. Now, that's all of the getting the data to S3, making sure it's in training and testing, and that's sort of standard data science stuff. Now, the Autopilot code, it's literally only a couple of blocks. So importantly, Autopilot only supports tabular data formatted files. So CSV is a great format to make sure your files are in. Each column contains a feature, so you can think of each column as a feature. You probably hear the word feature a lot, but it's basically a column with a specific data type, and each row contains an observation. There can be numerical, categorical, text, time series. There's a whole range of different things that SageMaker will accept. All files should have a header row. So there's some prerequisites. Like I said, there's some really good demos of, in fact, let me just share that now while we're here. That's a good segue. So I showed you this demo here. I have two other demos that you can also use as well that demonstrate different things. You can see them here: direct marketing, the customer churn, and top candidates customer churn prediction. So there's plenty of material if you want to experiment with these demos yourself. And let's pop that in the private chat there. Someone push through to the public. Cool. So let's come back. So we're onto the Autopilot code now. All we do is we specify our input and output locations using this transform here. We just print them out so we know what our input and output looks like, and you see there are 3 buckets. You can specify the type of problem to solve: regression, multi-class, classification, binary, but equally it will auto-detect. And again, that's another really cool feature. You haven't got to worry about what type of problem is this. It will help you determine that for yourself. Let's launch an Autopilot job with 20 candidates. So this is the code to do it. That's it. Create auto ML job. We give it our input, our output. We tell it how many candidates we want to run. So that's going to run 20 training candidates. And I'll explain in a moment how that works. If I was to run this now, it would start running in the background. So let's pretend it's running in the background. The reason I haven't done this, it just takes a bit of time, right? It can take a few hours to run some of these jobs. We also need a bit of code to track our Autopilot progress. And imagine we're in real time now. This is what it's doing. It's analyzing the data. It's doing some feature engineering. I'll run through these terms in a moment. It's doing something called model tuning, which is really, really important. And then it generates an explainability report. So that report tells you exactly what Autopilot has done. So what algorithms has it choose? How did it choose them? What were the scores? And I will give you a little a glance into where that lives in a moment. And so we've generated
how long did
2
that
notebooks.
take to run, Paul?
I think for my session, I think it took 3 hours to run this. Okay. But again, if you want to speed up these types of things, you can run less experiments. This particular job is configured by default to run 7 in parallel as part of the auto tuning. So in other words, it will run 7 jobs, and then when job number 1 finishes, job number 8 will take the learning from job number 1 and apply that to help tune the model better. So auto tuning is really the process of learning as you go as to how you can better tune the model. And it does that through something called a hyperparameter. So just to keep things really simple, just think of hyperparameters as levers in a machine learning model that you can effectively tweak like knobs almost on on a mixing desk, to give it a different type of sound. Maybe you want the EQ to go up, maybe you want the bass to go down, and that's a really good example of really, how the hyperparameter tuning sort of works, and it happens all in the background. You can think of it like tuning an engine. You can think of when you're tuning an engine, you want to change the mixture of going from this is old school engines, from the carburetor into the motor. And so that's another way of looking at hyperparameter tuning. The other analogy I like to use is quite a few of you probably play guitar. That if you play electric guitar, we don't like it when our guitars go out of tune, so we're using the little knobs at the end, which are hyperparameters really, to make sure the strings are in tune. So the word hyperparameter, hyper means to sort of be outside of something. It's the parameters outside of the training model that you can tune prior to it being trained. So hopefully I explained that okay. Some of these terms are a little bit tricky to take first time.
That's a tough one. I think you did a good job. We've got a question here for someone in the audience. And so Rye CS has asked, is that provisioning and executing the job on GPU-backed EC2 instance behind the scenes?
Yeah, so what's happening with the training jobs in particular, the training algorithm is then selecting the type of EC2 instances we want to run. They're actually machine learning instances, but effectively they're EC2. They have the ML dot and then the size. It might be M5 dot medium, for example, and it will run as many of those as it needs, and it will determine whether they need to be GPU or CPU. So there might be GPU, there might be CPU, depending on the type of algorithm that's used and depending on the type of result that you're looking for. But it does that automatically, and that's one of the challenges, right, of data science is which type of instance types do I need to run, how many do I run, and how do I shut them down when I've finished? Sagemaker does everything for you, and Autopilot does everything for you. The next question then tends to be, well, how do I know what instance did it pick? We can go through. Should we do this now? We might as well do it now. So we have a Autopilot candidate definition notebook that talks about what the machine learning did. I'm not going to go through it in detail. It's a very detailed and quite a complex beast. But let me scroll down and try and find the right. Here we go. So what it does, it selects 10 candidates, and you can see the candidate select there is an ML.M5.4x large, which will be either a CPU or GPU. That's a CPU based. So it determined that that is the best one to run with the XGBoost algorithm for this type of machine learning problem.
It gets more complicated than that as well, right? Because we're now starting to see specialized processes that come out for machine learning, right? So some specialize in inference, others in the training steps, some with particular types of calculations. Yeah,
absolutely right. Yeah. People often say, should I always run it on a GPU or CPU? And it really depends on whether you're training, whether you're doing inference, and what machine learning problem you're trying to solve. It's not necessarily that straightforward. It's I love that it takes care of it for you. You just run it and it does all that heavy lifting for you, and that's a huge benefit, right? Think how long it would take to work all these steps out.
There's another question, Paul, from Christopher23. And he says, I think I saw that there is also a way to see the entire SageMaker ML pipeline graphically. Is that correct?
Good question. I don't know off the top of my head. Certainly in there is another product called SageMaker Canvas, designed for business analysts. And that's very much a drag and drop interface where you can create machine learning models. And that could be one way that you might visualize your pipeline, but I'll have to look that up. I'm not sure off the top of my head.
That's what I was thinking, that it might be something to do with Canvas as well.
I was more thinking this one maybe. So there's actually SageMaker Pipelines. So you can see like the flows that you've got for your machine learning workloads, and you can customize those with pipelines. Yeah.
And that gives you that visualization component. Yeah. So we go into, for example, SageMaker resources. I haven't explored this, so I hope it doesn't break, and go into pipelines. Well, I haven't created any, but yeah, if there were pipelines in here, there's probably a way of clicking on those and then getting that visual. But this is where you navigate into pipelines from here. Cool.
There we go. Chris says thank you.
Great question. Keep them coming. Awesome. So let me take a step back. I'll just work you through what these components mean? What does analyzing data, feature engineering? So you can see it's taking care of all this. But what is it doing behind the scenes? Like I said, we really need to go through the explainability. Let me just scroll back. The explainability notebook. So this is called the Autopilot candidate definition notebook, and I'll show you how you access these in a moment. But basically, the machine learning, the SageMaker Autopilot will go through and analyze your data. So first thing it's going to do is, what's the problem type? Is it a linear regression problem, a binary, or multi-class? In this case, it's automatically detected it's binary, and it's producing then from that determination 10 candidate pipelines. So we saw one further down here. So DPP0, that's one candidate pipeline. If I scroll down, there's another one, DPP1. So it creates 10 of those.
So I find it pretty amazing, Paul. Like I was going to say, and then we had a couple of extra questions, which is good. But
cool.
I'm kind of blown away by the fact that it can, even though it took you 3 hours to do what you were doing in particular, like it's not only like, you know, run multiple models and worked out what the best fit is, and then run multiple iterations of the best fit model on the data to produce a result. And all of that's happening pretty seamlessly in the back end, right? Like if I was to, not being a data scientist, if I was to try and work out what the best model was for my data, I'd be sitting there for days, right? Like wasting GPU and compute.
Probably weeks. Yeah, days or weeks. Absolutely. And even if you had a data science background, there's a lot to grasp in the tool. Whereas as you can see, the Autopilot make things much easier. Like even the analyzing data, even does pre-processing. So it analyzes the data and understands, do I need to transform the data? You know, is there anything I need to do? Any missing values in there? It cleans it for you.
And I like the fact that you get the reporting at the end of it, because it's less magical. Like I would be worried about the magic behind the scenes.
Yes.
But considering there's reporting and you can see why and how it made that decision, it's pretty useful, right? And then you can kind of you can test that yourself if you really wanted to.
Absolutely right.
Yep.
So let's assume that our job is finished. So this is our auto ML churn job here. This is our auto ML job. I can right click and I can describe the job. And what I can do on the top right, I can open a candidate generation notebook, which I did before, and it's telling me exactly what Autopilot did. But I can also open the data exploration notebook, and it shows me what pre-processing and analysis it did on the data. And I can use that to then help me understand, is this data balanced? Is it biased? So for example, if I click on the open data exploration notebook there, which opens this notebook, very simple target analysis. It's telling me that I have two classes, so it knows it's a binary classification, and you can see it's fairly well balanced. I have almost the same number of false or zero target labels as true. So in other words, churn equals false and churn equals true, and that's important because I know my data is reasonably well balanced. And so this is what a normal data science would do. So, you know, even in terms of the pre-processing exploratory data analysis, it lays it out for you. I'm just going to scroll through very quickly. We're not going to cover this. This is Pearson Correlation. It does all this for you. So you can see whether certain fields are highly correlated and helps you with feature engineering later on. It also helps SageMaker with the same decision point too. And so it goes on. Isn't this incredible? I was blown away when I first ran this and went, wow, you get all of the exploratory data analysis, and you can see it's all written in English. And then you get the, what did it do in some detail?
Yeah. I mean, I didn't know too much about Autopilot, but I've been fairly impressed with it today. We did have a question from Perkinji, if I got that right, hopefully. So what's the biggest limitations of machine learning implementations today? Is SageMaker trying to mitigate the risks with Autopilot? I think that's quite broad, right?
Yes. I guess my view on this, so the biggest limitation, I guess when you say limitation, you mean, you know, of all the ML projects that we run, why do they fail? Why do ML projects fail? And I think for me, the simple reason is not every solution is an ML solution necessarily. We've got to understand what the business problem is, what the business case is, what are we trying to do? And if we do that work and we understand that indeed this suits machine learning, then we're highly likely to reach an outcome that we might work for the business. And a lot of the time, we don't honestly know. And then the biggest challenge, even once you've got the business case right and you've got the business definition very clear about the goals that the business want to see at the end of it, you then got to get the data, you got to find the data, you got to clean the data. you ask any data scientist, they'll probably spend 70-80% of their time cleaning and finding data, and then another 20-30% doing training and inferencing. So for me, I think that's where the biggest limitations are. So when SageMaker can start to do some of the pre-processing for you and start to analyze that problem for you, that really takes you a long way. It's certainly a long way to go. This is very early days of machine learning. I don't know what your thoughts are.
I was going to say from my perspective, there's probably two main things that I see with customers. The first is, data scientists are amazingly smart people, much smarter than myself and Paul and everyone else.
Yes.
But like, you can live in a laboratory. I can't even speak today. Laboratory. And you can be testing these things and building algorithms and all of that. But there's a different type of work that's needed to make it production ready to be released to a business. And so sometimes I can kind of see that the ML teams are quite distanced from the teams that are able to manage production and teach them how to do that, or even do it for them, and the business side. And the second thing is, I think there's a bit of democracy that needs to happen, and I think that's the part that SageMaker is really stepping into. Not everyone's going to have a couple of $100,000 to pay a machine learning scientist, right?
Yes.
So SageMaker effectively allows us developers and even non-developers, business analysts in some cases, right? We're trying to make it simpler, be able to produce models and machine learning models for data sets that they do want to have, something performed on, or doing some research or building a small feature in an app. So this kind of helps to make machine learning more available to everyone. I think that's my view on SageMaker.
Yeah, that's what I think too. And I think I made the analogy when we were chatting about it the session that, let's arbitrarily roll back 10 years where a developer was building some sort of application. You didn't care so much about how it looked and felt and how you interacted with it, as long as it did the job. But now, interacting with and how the application feels and looks and operates within the customer is part of that whole team. And so when we start making machine learning accessible and understandable by the whole team that are owning a product, then it starts to close those gaps between a team of data scientists that says, hey, we've got some analytical outcomes, and merging that into the teams and developers that are building applications, say, hey, we can use that to make something better or different or more personalized or more accurate for our customers and what we're building.
Yeah, ML ops kind of falls into that. I can kind of see we've prompted the chat, which is really nice.
Yes.
so ML ops is definitely kind of parts of what I've been thinking, right? Like operationalizing machine learning model, productionizing it. Those are the things that are quite new for a lot of businesses that do have machine learning scientists. I can see Perkins also called out what's the value of democracy. I think it's the same as what's the value in making programming easier for non-programmers, right? Machine learning scientists are still going to be the absolute, bee's knees when it comes to, doing what they do, and they're going to do a far better quality job than a software engineer that's kind of learning as they go, trying to work on a particular use case. But having it there means that the business don't need to rely on their machine learning scientists for everything that a developer wants to simply put in their app, image recognition or sentiment analysis on comments that users are making in the app. So democratizing is good for everyone, and even in the development world, you've seen that with no code, low code type solutions, honeycode. We do a lot of form building as developers, but that form building doesn't necessarily need to be done by us. We can build out backends in far greater detail, have more time for that type of work, or on the front end actually spending time making sure that the front end's in order versus what it looks like stylistically. So democratizing everything is always a good thing for everyone, and you still need developers, you still need machine learning scientists. It's just they get to kind of do the more interesting work, from my view. We're never going to have enough developers in the world, I can tell you that. We're never going to have enough machine learning scientists in the world.
Correct.
Yep.
And the other one, security, of course. You never have enough, security people to keep everyone safe. And it's all part of that same continuum. You talk about DevOps, developers and ops being in silos. ML ops is the same. ML SecOps is the same. DevSecOps is the same. And even in a business, it's the same problem you have with HR and finance and, people in the field. You have those different silos. So the idea behind the technology, if it can be democratized, it starts to span those silos and becomes more widely adoptable. And it means, more people can do more magic sooner, faster, better, that type of thing. So I completely agree, Matt. Absolutely.
Yeah. I didn't want to miss one of the questions that we did have. So Rio CS mentioned, in theory, if I could get my hands on great sports data, can Autopilot determine the most critical feature that determine if the outcome's W or L? Yeah.
So my advice is to try it. So whether your model. So this one thing to have an idea, I guess, or a business use case for machine learning. You then need to do a series of experiments and see how accurate your model is. It'll never be 100%, but assuming, of course, it does have the features contained within the data that can accurately predict win or loss, then the answer is yes. But I suspect it's not that simple. Otherwise, people would have done it already. People often say the same thing with share prices. If I put, a whole load of share price data with things that have gone up and down, will it accurately predict? And the challenge with share price data is just because something went up or down yesterday doesn't mean it's going to do it tomorrow. And so that's the challenge.
Historical trends can help somewhat, right? But I think of sports players, right? Like someone's broken their leg, that wouldn't have been worked out by machine learning. Somebody's just having a down day. They've got like a cold or a flu. So, their performance is impacted. Somebody spent, the last week having beer and pizza celebrating, like all these things like means that like the historical data, you might make some money off of it if you're doing it for betting, but you might not, right? Having looked through the chats as well.
But that's a great question. I would say try it, share it on GitHub, and then message me and let me know how you went, what results you found. I'd love to know whether you're able to crack that one. But yeah, you're right. There's a lot of data that's not included in the data set, like pizzas and other things. So yeah, that's absolutely right.
I can see Peer Track as well. I always wonder if, as experts, triggered as I am by the use of AI or ML. I've just given up. I just interchangeably use them these days. Like AI is not ML. ML is not AI. But when you have a conversation with people over the last 5 years, we've just kind of gotten used to interchanging them. So you can work with all different stakeholders that have different levels of understanding.
That's what it is, right? Like businesses are saying, like we need big data, we need artificial intelligence, we need machine learning, and they know they need things, but it's still like largely immature. Like people don't quite know what they need, but they know they need to be going down this path. So that's probably why we're starting to see these tools become accessible, because it is having a broader reach within the industry. It's not just isolated to some really deep specialists and everybody else at the other end, misunderstanding how that could be used and what it could mean for your organization. We're starting to see that gap closed.
Yeah, absolutely. Cool. Do we have any other questions?
Sitting those through.
The last question here is for this example from Rice CS. For this example, can this determine the most influential features, ones that most closely track to customer churn?
That's a great question. So let me show you something. Let's have a little look. Let me just think where this lives. Yes. So what we're showing on the screen here is all the different models it ran. It ran 20 of them. And you can see here, it's got a F1 binary score. Just trust me on this, but this is the score that it's measured, and it's just going to pick the highest one. And it's picked, this is my best model. So if I open the model details, guess what? It's showing the explainability here. It's showing which of the features are contributing to that end variable. So eve minutes, night charge, night calls in that order. And it's got a little score there, correlation score. So this is determined using something called Shapley values. And essentially, the Shapley value system came from gaming. Basically, sort of a bit of a mathematical formula that helps understand the contribution of each player to a game. And the idea behind that was that at the end of the game, there was a pot of money. How do we distribute that money to all the players? Well, if we can ascertain a method for understanding the contribution of each player, we can give the highest contributing players the higher number, and the lower people the lower number. And so they took the idea of the Shapley values, and that's what AWS use now in SageMaker Clarify, it's called. So SageMaker Clarify is our tool for understanding bias, understanding how features might contribute to the end outcome. And so this is what you're seeing here.
I think the audience is impressed looking at the comments.
Oh, really?
God,
cool.
That's awesome. It's really cool. So I
think I'm impressed too.
Yeah.
It's a pretty amazing feature set and tool. Yeah.
You're convincing me to give up PyTorch and go to SageMaker Studio a little more again.
Yeah, absolutely. Yeah. Well, this is the thing. I'm a big fan of low code and no code, so much so internally at AWS, they reached out prior to Christmas saying, who's interested in low code, no code solutions? I put my hand up, and I was lucky enough to be chosen as one of the champions in region. So I'm focusing on SageMaker Autopilot. You can see why, right? And then there's a number 2. I'm going to look at Canvas. There's also Wrangler, which is for data visualization. And there's a 4th one that it will come to me. It escapes me at the moment. But there are basically 4 low code and no code solutions that we're focused on around the world to accelerate knowledge and to share with customers. So this is very much part of that first cab off the rank, if you like, of being a champion, of showing you guys a little bit under the covers and showing you some of the democratization of the machine learning. So
the other one's Honeycode, is it? Is that right?
So yeah, there's some other tools in other areas. This is just for the machine learning, what we call technical field community. Yeah. Yep. For people that would probably think, what does that mean? Oh, we have groups of people in Amazon that specialize in things. So I specialize in AI and ML, and it's just part of that group.
Paul's builder tools. I'm mobile and front end. Paul might join me for mobile and front end as well as builder tools sometime this year, if I'm lucky. Yep. I know we're right on time as well. I'm more than happy to keep looking at a couple of things. If the audience is interested in Paul, you've got some extra things to show off.
I do. I always have too much, don't I? Which is good, right? So let's have a little look. I'll tell you what. Should we? Oh yes. Let's go into let's pick something a little bit more advanced. So let's see how we go. See if we don't lose people.
We did get a quick question around costs.
Go for it.
So like to develop the churn model, right? I'm just looking at 3 hours based on like EC2 pricing, right? Is that correct for SageMaker, or is it a little more complicated?
I say SageMaker has its own pricing. If you look at ml.m5. whatever size we use, there's separate SageMaker pricing. So it is different to the EC2 pricing. But from memory, I think it was less.
It's not that significant. It was like a few cents per hour, I think, for each.
Yeah, correct.
Yeah, yep.
I think to run this demo, maybe I have to have a look. Maybe $20, $10. It was around that sort of figure. Certainly less than 50. So if people are a little bit worried around, the cost side of things, with Autopilot, choose a small number of candidates. So I choose 20. You can choose 10 or even 5. Or if you wanted, you can just run a single experiment. You just run one and just learn from how it works. That's probably the cheapest way of doing these things.
I was going to say there's a free tier for SageMaker too, right?
Oh, good point. Yes.
Yeah.
Absolutely. Yes. Yeah. For people not used it before, absolutely, there is a free tier. Sorry, my bad. Yeah, absolutely. That will help you get started. But it's a common problem. People are often a little bit worried about, how much will it cost me? We'll run one experiment, see what the cost is, then run 5, then run 10, and you'll see that it's very, very low cost. You're talking dollars.
Yeah, and you do get 250 hours of MLT-free medium instances in Studio Notebooks. I've just sent the link through.
Wonderful.
You got 50 hours of training on M4 XL instance types or M5 XL instance types. So if you want to do something and knock up an AWS account for a few hours, like you'll be able to fit on the free tier fairly easily, just to get started with it. And
I encourage everybody listening today to record their experiments in a little notebook and to share it, blog about it, maybe share it, obviously securely in GitHub. Make sure there's no confidential information in your models that you're not willing to share. But I'd love for you to reach out and tell me how you're going, and what great results you're getting and what you're learning. It's a great learning tool as well as a data science tool. It's phenomenal.
And we did have a question around, is the costs very similar? So I mean, I've just linked the costs. So have a look through that pricing. It's very similar to EC2. It's just a little bit more expensive. The caveat that I always put around it, and it is GPU instances can be expensive, right? And you might add one, just without thinking, where you're clicking through the options to do some training. So just be cautious of that, because the GPU hours can cost a little bit. But if you follow machine learning scientists, on YouTube and online, you'll see a lot of them will actually, rather than have a fully kitted out like laptop or desktop with a giant graphics card, a lot of them just use cloud instances, because they've got a few hours to run a test, and they do that every couple of weeks or every week. And so it ends up being significantly cheaper than buying specific gear at home to do machine learning. Unless you're a video gamer and you've got like a high-end graphics card already, it's the best way to go.
Absolutely. And the thing I like about the Sagemaker Autopilot, like the question alluded to earlier in the chat, it will take care of those machine learning instances for you. It will spin them up. It will run them for as long as you need. If you're only running, say, 10 instances, and you're only up for 20 minutes, you only pay for 20 minutes. So cost, and you bill by the second. So it's a very cost-effective way of doing things.
There's one more quick question, and I say, is Rust implemented in Sagemaker? Now, I know we typically have a lot of people that are using JavaScript as well, though Matt and I often talk about Python. I would like to hear what you say about this, and whether you're seeing anybody looking to look outside of just using Python for their machine learning at the moment.
Yeah, I must admit, I only came across Rust last year. Probably middle of last year, and I haven't done a lot of work in terms of understanding a bit more at Rust, but I know when Werner Vogels gets all excited about Rust, there's something really to look at. So it's very much on my to-do list. But I'm just showing you here some of the images available. You can see this PyTorch. To my knowledge, there's no Rust. There is now integration with Aws Studio as well, which is the other thing, but no Rust at this stage. But I'm sure if Werner's getting all excited about Rust, it will be coming very soon to a number of different AWS products. Not sure when it will come to SageMaker, if at all.
Yeah, SageMaker has examples using the SDK for Rust, right? But the kind of like the native language for SageMaker would be Python, right?
Yeah,
because it was a programming language, developed by a statistician, if I remember correctly, Guido van Rossum, and so it does really well at kind of like machine learning tasks, and then under the hood for the stuff that needs to be more low level, it's relying on C++ essentially.
That's a really good point. Yeah, I was thinking within the SageMaker. I mean, it's too long, haven't I? Within the SageMaker, but you're right. There's SDKs you can use, of course, and Rust is one of those. There's a whole range of them. So yeah, that's a really good point. Awesome. Cool. Have we got time for a little bit more, or?
Yeah, let's go for a little bit longer. I think everyone's interested in seeing a little bit more, and they've been impressed so far.
Let's see. The schedule is open, so we're not blocking anybody, so we can.
Okay, that sounds really good. So I'm going to move to a little bit more advanced topic. So if hyperparameters wasn't enough advancement for you, we're going to look at the F1 score. So the F1 score is something that SageMaker uses to determine whether that's the best model or not. Now, I might lose a few people here. We're going to talk very quickly about a confusion matrix, and it's called a confusion matrix for good reason. It confuses everybody. So you may have seen this before. Hopefully you can see this clearly on my screen. You basically have true, false. So at the top here, let me just scroll down a little bit. At the top here, this is reality. And at the bottom here, this is the predicted. So what we use a confusion matrix for, we use this as any part of any binary classification problem, and it helps us tell us how our model is performing. So ideally, we want high number here, and then a relatively low number, false positive, false negative. So true positives are things that are true. True negative things are false, and they are false. And these two is where everybody gets confused. So let me scroll to the next diagram. And I use a COVID test result example to understand how this model works. So again, the green is where I want my machine learning model to be accurate. So it accurately predicts I'm sick because I am sick, and it predicted sick. This is one I don't want necessarily too many cases. I am well, but I was predicted as sick. The false negative I am sick, but I was predicted as well. And the final thing, I am well. And so hopefully this helps better understand what false positives truly are and what false negatives really are. So if I think this through for a COVID test, so maybe I could put machine learning aside and just talk about, being test positive and negative for COVID. I probably don't want too many. Let's have a look. I don't want too many false negatives, do I? Because I don't want people that are actually sick and the test is telling me that they're well. So I want really low numbers. I probably want 1 or 2, out of every 1,000. Whereas in the top right case here, I am well, but I was predicted as sick. I'm probably less worried. Because if you're predicted as sick, it's not great for the end person, of course, but it means they're not in a community spreading the virus. So that's one way of understanding confusion matrix. Confusion matrix. Now you probably think, where am I going with this? There's a couple of terms here called precision and recall. To keep it really, really simple, I've got all the details here, but precision is understanding how many of these exist as a proportion of these, and recall are how many of these are there a proportion of these. So in other words, I want the proportion of these to these and these to these to be fairly low. So we calculate using a special formula what those two things are. And then the F1 score is what we call the harmonic mean between those two values. So ideally, we want those two values to be as high as possible, assuming our model is working correctly and predicting accurately. It's not over or underfitting. And effectively, that's what the F1 score does. Harmonic mean is just it's a little bit like arithmetic mean, but it's a different formula and it's used for ratios. And because precision and recall are ratios, harmonic mean is the better way of doing it. So arithmetic mean will be incorrect mathematically. So that's a simple way. Did I lose anybody along the way? Precision and recall is where it gets tricky. But that's how you determine whether your models are good or not.
I think it would be hard to reiterate that immediately, but I think the message came across.
Yeah, cool. Yeah, it's not an easy thing to explain. And then down here, I've got a little bit of information around overfitting and underfitting. So these are two things that we don't want to happen with our machine learning model. So overfitting and underfitting mean we're either fitting the data too well, so overfitting. So we have high accuracy on our training data set. Maybe we've got 99, 100% accuracy. But then when we test on our separate piece of data that the model hasn't seen, it's got very low accuracy. And the reason being, it's just learnt by rote, the data points. It's a bit like someone going to an exam and knowing all the exam questions up front, and then going to the exam and answering because they know all the exam. Well, that's no way to test knowledge, is it? And the overfitting is the same problem. And so you're going to get likely low accuracy on that new data. And so when you put that in production, it's going to be rubbish. It's not going to work very well. So a couple of techniques to help with that. We have something called early stop. In other words, we don't overtrain our model. We can add some noise into the data to help regulate the data and help the machine learning algorithm perform a bit better, or we can get rid of some features. So you saw in our example, we had, off the top of my head, probably 20 other features. If we were getting overfitting, and by the way, Sagemaker Autopilot takes care of overfitting and underfitting for you, but with the techniques that it uses under the covers, which takes many weeks or months or even years for data scientists to learn. This is avoided. And then underfitting is the opposite. The accuracy is too low to start with because our machine learning model is just not very good, and that's just on the training data. And so there's some techniques for getting better underfitting. Models aren't underfitting. So things like training longer. Let's train it for longer, or let's provide more data, more meaningful data.
I learned about overfitting with Deep Racer, where I'd build a model and it ran really well around one track. And it was like performing really, really nicely around like the original reInvent 2018 track. The moment you take it and put it on any other track, it just performs like garbage. So yes. Yeah, I learned. That's how I learned about overfitting and underfitting.
That's a really good analogy. Thanks for sharing, Paul. That's awesome. Yeah, perfect example. Cool. Excellent. I think that's probably the most that I've got, I think. Yeah, that's probably everything I have in the kit bag. We've done well in an hour and 15. Do we have any other questions?
Yeah, feel free to ask anything. We did share Paul's details if you want to connect with him later on as well. Let me just put those back in the chat for everyone.
That'd be great. Yeah.
There was also a couple of people that said we'd like to see more. So you're probably going to have to prepare a couple of sessions on some of the other tools. And probably like really relevant is Christopher asked, which is I was going to comment on as well, is like what once we've built the model, like what do we do with it? Like how do we deploy it? How do we use it in production? So
Yes.
deploying the model is something we should dive into as well at some point.
Yes, I can quickly answer that question. That's a great point. So we didn't get as far as I wanted into the demo. So we got through all the way to having a training model, and SageMaker will select the best training model, and then we have the option of deploying that model. So that code, we never got to it, but in here we've got the results. And basically what we can do, we can then deploy the model, and then that test data we reserved right at the beginning, we can use to then test our inferences on that model. So that's the inferencing stage. And so again, you can use SageMaker to host that model in our GUI, for example. Let me just go file. The other way you can go and do a SageMaker Autopilot model is through here, new experiment. So Autopilot settings, and down the bottom here, we've got the same in the code as well, but here we can auto deploy it off and on. So if I leave it on, it will look at 10 training candidates. It will then run 20 training jobs to find the best model. It will find the single best model. It'll automatically deploy it for you. And then you're ready to run an inference against it. So you give it a new set of data, which would be the test data, and hopefully it will run again. And you'll look at your confusion matrix and you'll make a determination as to whether it's successful or not. And then at that point, when you're happy with that, you might do multiple iterations of that. You eventually get that into production. So it's just like a DevOps pipeline, no different. You move through different stages. You move through a development environment into a pre-prod, into a prod, and you might do testing and validation at each step. So you might do it multiple times. Here, we've sort of accelerated it a bit, but that's a really good question, and that's really, really important. Oh, and the other thing as well, once it's in production, things change. Things are changing all the time. So, for example, the mathematical models that you might have created pre-COVID, if you're taking COVID data and trying to predict certain things around maybe the spread of the population, will be very different to now, will be very different in a year's time. So what's really important with machine learning is you need to check your models for model drift and understand when they're drifting, and then rework those models. It's just like any sort of, it's just a form of technical debt, right? It's no different from when you're writing code. You're constantly improving it, constantly improving the UI, new features. Machine learning is no different. The environment's changing around it, so you need to keep those relevant. So it's a form of technical debt. So the performance drift, and there are tools in SageMaker that monitor that thing, will tell you and allow you to understand when you need to start changing that model and redeploying it. So that's a really important point. So it's not static. Cool.
Perfect. Well, I think let's wrap it up for this week. It's been a fantastic first episode back from the Christmas holidays. So thanks, Paul, for joining us. We are going to have you back on at a future date. So there's a billion things we could talk about SageMaker, and I believe the audience all loved it. Next week is Australia Day. Weirdly on Wednesday, so it's a public holiday in Australia, but Paul and myself, if Paul's shed's set up at his new property, which you'll be able to see on the live stream, if that's ready to go, we'll plan to stream at the same time. We've got some AWS personalized content that we'd like to show. For those that aren't too familiar with it, personalized is all about making predictions as well, and so we've got basically a website that you can visit, and on that website, based on your browsing habits, it's going to give you links to particular pages that it thinks that you would like also. So personalized you can use for a recommendation engine essentially. So it should be interesting, and we have done something a bit more unique than movies that you might like based on other similar people. Like we've done it fully based on how other people have navigated the site similar to you. So it should be fascinating. Other than that, thanks everyone for joining the first episode. Paul Colmer, hang back with us. We'll end the live stream now. Anything else that either of you two want to add, or else I'll wrap it up for today.
I'd just like to thank you both for inviting me onto the show, and thank all your viewers for such great questions. And I just love this side of engagement. So please reach out to me on Twitter, LinkedIn, and we can keep the conversation going. But thank you so much, guys. Really appreciate it.
Yeah, thanks everyone. Special thanks to Paul for coming along.
Excellent.
Take care.
Thanks everyone.
See you next week.
Take care,
Bye.
guys. Bye.